Alright guys, so here's a little video on Gauss-Jordan elimination. Last week we saw Gaussian elimination, which the goal for us is to use row operations to get the matrix in row echelon form. So now the only difference between Gaussian and Gauss-Jordan is for Gauss-Jordan elimination, you want to put the matrix in reduced row echelon form. So that's very important that we know that distinction for Gauss-Jordan. Our goal is reduced row echelon, and once we get kind of down to the end, I'll remind you of what that is. So I picked a system here where our answers don't work out quite as pretty as they did for a lot of the other matrices we saw last week to kind of get one where things get riled up a little bit. And you can go a very step-by-step method for Gaussian and Gauss-Jordan elimination, where kind of we have to get this first spot as a leading one and then get the zeros underneath. But honestly, the order doesn't really matter for those steps. So I'm gonna do them kind of backwards here. I'm gonna make my first goal to get zeros underneath in that first column, because if you notice, the 2 will be more helpful, or a little bit easier at least, than if I divide that first row and have decimals right now. So I'm going to clear out these first 2 rows, and make sure you're paying attention to how I write my row operations. You can only use 2 rows at a time. I don't want to see 3 rows at a time. I don't want to see all these compound movements. This is pretty step-by-step and sometimes does take a couple steps. So I'm going to do negative row 1 plus row 2 to clear out that second row, second column, second row, start as a 0. So I'm going to rewrite this first row. And then, like I said, I never like to subtract, so I'll always do the negative plus, but row 2 minus row 1 would be the same thing here. So this will work out to be a 0, this will work out to be a 5, got another 5 and a 2. And I can change the third row since I haven't done anything with that yet. I'm going to also do negative 3 row 1 plus row 3. So notice I'm only using, 2 rows at a time to change. I'm writing my row operations, which is something I will look for when you guys do these on your own. So this will work out to be a 0. 8 plus negative 3 will be another 5. 18 plus negative 9 will be a 9, and 5 plus negative 3 is a 2. Alright, so that's what I have so far, and our next goal will be, so again, we have a couple options here, like these I need to get to be the leading ones, and this guy I need to get to be a 0. So the order that we do this doesn't matter as long as that's our goal at the end. So I'm going to next actually get that 5 that I highlighted in red. I'm going to get that to a 0 because I can use now that second row 5 to help me out. So I'm going to do negative row 2 plus row 3. Rewrite my matrix out here. Negative row 2 plus row 3. And put my rows back in. So by doing it in this order, I'm just avoiding fractions. So negative 5 plus 5, negative 9 plus 5, or negative row 2, so negative 5 plus 9 will give me a 4, and then negative 2 plus 2 will give me a 0 here. Alright, so now as my last step for Gaussian, I need to get the leading ones in every row. So I'll divide the rows by their, prospective values. So I'm going to do row 1 divided by 2, row 2 divided by 5, and row 3 divided by 4. And this would put me in row echelon form. And fractions are okay. We'll clear them up in a second. All right, so this would be our row echelon form. For Gauss-Jordan elimination, we need to get to reduced row echelon form. So I want to clear all these spaces out, making them zeros. So I'm going to kind of work backwards and do the same idea here that we did before. So to clear out this 1 in the second row, I will do negative row 3 plus row 2. I'm also going to clear out this 1.5 up top, so I'll do negative 1.5 row 3 plus row 2. So I'm using the leading one in that bottom row, since there's zeros in these other spots, to help me out with this. And you guys can use a scientific calculator or use your graphing calculator, as a scientific to help you add and subtract. Nice addition here because that last row is a 0. And then for my top row, I've got 1. This guy's still a 0.5. Negative 1.5 row 3 plus row 2, that looks good. Negative 1.5 row 3. This should be a row 1 over here. Plus row 1, again, will be a 0. So far so good. Last thing I need to do is clean up this 0.5. So I'm going to, let's see where I want to make a little more room over here. I'm going to erase the original ones I have on this side and just go over here to finish up. All right, so now going back this way, the last thing I'm going to do is negative 0.5 row 2 plus row 1 to clear out that 0.5 up there. So I've got a 1, I've got a 0. Luckily this guy's a 0, so that's nice. And so the only thing I have to deal with is this 2/5. I'm going to get my calculator. Negative 2/5 plus 1/2. And I got a 1/10 there. Just making sure I added right here, plus 0.5. I actually misspoke. I didn't multiply by that negative 0.5, so let me fix that. If I do negative 1/2 times 2/5 and then add a 1/2, I should get 3/10 as my answer here. All right, so then this is successfully our reduced row echelon form, which is our goal. And hopefully we can see from here, from reduced row echelon form to get our final answer is super easy because I have 3 equations with only our variables. So I'm going to get x equals 3/10, y equals 2/5, and z equals 0. So that would be my solution for this matrix. I'm going to put up a couple more examples, and you guys try it out. So again, just don't be afraid of decimals. You can use your scientific to help you out, and good luck.